Hello everyone. Good afternoon, guys. I hope I am audible. Jan B. Kolhapur. Good evening, Jan B. Kolhapur. Okay. So yeah, I hope I am audible. So good afternoon to all of you. Those who are watching through YouTube as Zoom. Okay. So my name is Rahul, and today I will start uh, method of differentiation. Okay. So what we have seen in the previous classes. Okay. So yeah, so two classes is already done. Okay, the last class we were discussing about differentiality of a function. Okay, and there are some portion left, that is like important results on some points are left. Okay, so what I'm gonna do, I will simply revise. I will tell you all those points first, and then we will proceed for the method of differentiation. Okay, so meanwhile, if you are having any problem, you can drop your doubt in the chat box. Okay, so let's start, guys. Okay, yeah. So I will simply what we were discussing in the previous class. So differentiality. So what is differentiality? So I have told you there is a two meaning of differentiality. One is the geometrical meaning, other one is a physical meaning. So what is geometrical meaning? It is nothing but if there is a curve y is equals to some f of x, then if we are drawing a tangent, then slope of the tangent will be nothing but derivative. That means dy by dx. Similarly, physical meaning of derivative is what? It is nothing but rate of change of function. Means rate of change in y with respect to rate of change in x, or rate of change in dependent variable, that is y, with respect to change in change in independent variable, that is x. Okay, and then I have told you how to check the differentiality of any function. So you need to find the right hand derivative or left hand derivative. I have also told you the formula for it: f dash a plus, that is f of a plus h minus f of a divided by h. So this is your right hand derivative, RHD. And if left hand side, it is f dash a minus, okay, f dash a minus f of a minus h divided by minus h. Okay, so these are the two things that you need to find, that is LHD and RHD, and provided that the limit should exist and it is finite. Okay, so the condition for the differentiality is that if any function is derivable or differentiable at x equals to a, it means LHD or left hand derivative should be equals to right hand derivative, and it should be a finite quantity. Then only we can say that it is a difference. Okay, and also this geometrically means that a unique tangent with finite slope can be drawn at x equals to a. Okay, so the unique tangent should come with finite slope because it should be finite, and it is nothing but dy by dx. Okay, so it should be a unique. Okay, the tangent should be unique with a finite slope. Then only if different slope is coming, it means what? LHD is not equals to RHD. So it will be a problem. So tangent should be unique if you will see geometrically. Okay. And so these are the things that I have told you. If there is two things, that first we need to find differentiability at a point, and other one is differentiability in an interval. So if we are finding differentiability at a point, so again you have to find right hand derivative, left hand derivative. If both are equal, then it is differentiable at that point. Okay, and these are the some results on the differentiability that we have discussed in the previous classes. Like the first one is this is nothing but right hand derivative. This is left hand derivative. So same thing, nothing changes. Okay, and then other thing is that if any function is differentiable, then it has to be continuous also. Okay, all differentiable functions are continuous. Okay, but suppose p is not equals to q, means left hand derivative is not equals to right hand derivative, then function is not differentiable or derivable. Okay, so function is not derivable or differentiable. And the other thing is that there is some possibility that all differentiable functions. Okay. Hello, Janvi Kolhapur. How are you all? Okay. So I was just discussing about the results on differentiability. Okay. So what are those points? LHD is equals to RHD. Then it is differentiable. If any function is differentiable, then it has to be continuous. And if left hand derivative is not equals to right hand derivative, then function is not differentiable. And the important thing is that because it will need in this so many questions that function, all continuous function are not different. All continuous function are not differentiable. There are some functions where function will be a continuous function, but it will not be differentiable. So those kind of functions which is continuous but not differentiable, in that case, what we will check? We will check the graph. Okay, graph. And if in the continuous function, if at any point there is a sharp corner or sharp turn, then at that point we will say that the function is not differentiable. I have taken one question in the coming slide. It will be clear. Okay, so that's why. So these are the points that you need to remember. If any function is continuous but not differentiable, then there will be a sharp corner. At that point, it will not be differentiable. Okay, is it clear, guys? JNB Varda, JNB Kolhapur. Okay, so now this is differentiability in an interval. That also we have discussed that if any function is differentiable in an open interval a to b, then you have to check at each and every point in between a to b, right? The first thing. And the other thing is that if we were talking about closed interval a to b, then all the criteria will be applied just like open interval, but there are two extra points. One is a and other one is b, that is both are included. So at a you have to find right hand derivative, or at b you have to find left hand derivative. Why? Because in the yesterday's class I have also discussed that if there is a graph, okay, like this. Okay, so suppose this is a and this is b. Okay, so for a point there is no left hand derivative, and for b point there is no right hand derivative. So we will not talk about left hand derivative for a, and we will not talk about right hand derivative for b. Before that, because we are only concerned with a to b. Okay, so you have to check two extra point, that right hand derivative at x equals to a and left hand derivative at x is equals to b. Only we will talk about this and this. Okay, so this is clear. Okay, there are some theorems that we already see ki both functions are differentiable, then the sum and difference of both the functions or product of both the function or division of the both the function will be also be differentiable. Okay, if one function is differentiable, other one is not differentiable, then the sum or difference will not be differentiable. But we can't say anything about product and division. Okay, it can be differentiable also, not differentiable also. Okay, but sum and difference, if one function is differentiable, other is not differentiable, then sum or difference will be always not differentiable. Okay, so just remember these points. It will help you in solving question quickly. Okay, and suppose there are two functions f of x and g of x, both are not differentiable, then what? Then we can't talk about sum on difference on product. It depends on, varies from function to function. Okay, in some of the cases if both are not differentiable, but still sum or difference on product can be differentiable also. But in most of the cases it will be not differentiable only, but some of the cases it will be differentiable. Okay, that we have also already seen in the previous classes. Okay, hello JNB Rajkot. Okay, so now these are the very important results. We are looking at the hello, yeah. So these are the very important results looking at the solving questions, like important results, like every polynomial, constant and exponential function is differentiable at all real number. Okay, just remember this thing, every polynomial, constant and exponential function is differentiable at all real number. Okay, the first point, okay, it is proved already. So you can check it also, but it is already proved, so better it to remember. Okay, the second thing is all the logarithmic function, trigonometric function and inverse trigonometric function are differentiable in their domain. So whatever the domain in which they are defined, in that domain, all the functions, logarithmic, trigonometric and inverse are differentiable. Okay, the third one is the sum, difference, product and quotient of two differentiable function is differentiable. That we have seen in the previous slide. Now, same thing I was talking about. If all the functions are differentiable, then sum, difference, product and quotient will be differentiable only. And this point also I have talked that every differentiable function is a continuous function, but converse may or may not true. But all the continuous function can't be differentiable. In some cases, it's not differentiable. For that, what you need to see? You need to see the sharp corner in the graph. Okay. 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 So any doubt till now? So these are the very important results. So yaad rakhna hai aapko. Okay, so these are the some examples. Okay, you can see every polynomial, exponential, logarithmic, trigonometric, hyperbolic. Okay, here are some examples of some non-differentiable function like mod x. You know that we have discussed in the previous class. If mod x, so it is not differentiable. Why it is not differentiable? It is continuous, but at 0 it is sharp corner. So at x equals to 0, it is not differentiable. Okay, so these are the results that you can see. Okay. So now we will see one problem. I think in the previous classes for you guys, I have solved this problem, I guess. So I will skip this question because I hope you know this question. What I will simply remind you the things that the function is differentiable everywhere. Okay, they are saying that find the values of a and b so that function is differentiable everywhere. Okay, so if you will check x is less than 3. X is less than 3 means they are talking about minus infinity to 3. Okay, minus infinity to 3. So in minus infinity to 3, there is a function ax square minus bx plus 2. That is what? A quadratic polynomial. Okay, so minus infinity to 3, you are very much sure that this is a polynomial function, quadratic polynomial. So polynomial are always differentiable at any real number. So you are so sure about minus infinity to 3. If x is greater than equals to 3, it is bx square minus 3. You know that again from 3 to infinity, it is bx square minus 3. It is always differential, but there is some chance that at exactly x is equals to 3, it can be not differentiable. So we will check at that point only. Why? Because the functions are changing at x is equals to 3. So at that case, what you need to see at x is equals to 3, just check differentiability. Okay. Like f dash 3 plus or f dash 3 minus. And then you will get one equation that I think for you guys, we have solved this problem. Okay. Already we have done this problem and you will get one equation, but there are two variables. So for that, you know that if a function is differentiable, then the function will be continuous also. So just check the continuity, like LHL is equals to RHL. So in both the cases, you will get one equation each and then just solve both the equation, you will get the answer. Okay. So this is the problem I have told, I have given to you, right? I hope you have solved this. If anyone has solved Janvi Rajkot, you were there in the previous class. Okay, Janvi Silvasa was also there. So can anybody tell me what will be the answer of this question? Anybody tried this? Okay, same type of question, guys. This is gx, right? It is equals to k. root x plus 1, 0 to 3. And this is mx plus 2. Okay, so this function is differentiable. Okay, it means they are saying that from 0 to 5, it should be differentiable. Okay, so we know that this is a linear polynomial, and this is also, if you will say x is not x, if x is greater, x should be greater than -1, right? Then only it will be defined. So domain is x is greater than -1, and we know that ki 0 to 3 it is always defined because it is always greater than -1. So no problem with that. This is also one kind of equation. This is also linear polynomial. So I can say that from 0 to 3, okay, 0 to 3 it is differentiable. Okay, but there is a chance that at 3 it is changing. Okay, so we need to check the differentiability at what? X is equals to 3 point. So we will check differentiability. Okay, we will check the differentiability at x is equals to 3. So what we need to do? We need to find f dash x. I have told you either you can find LHD, RHD, but there is a simple thing that you can do. F dash x, sorry, here it is g na. So g dash x is equals to, if you will do the derivative, you will get k, and root x plus 1, it is 1 divided by 2 root x plus 1. Okay, and 0 to 3. And mx plus 2, if you will do the derivative, it will be m only. So 3 to 5. So now we need to find the left hand derivative. So just find the derivative. We have already done it. Now we will find g dash 3 minus. This is LHD. So from here, if we will put 3 minus in this case, so what it will be? K into 1 divided by 2 root under 3 minus h plus 1. So it is h tending to 0, right? This is h tending to 0. You can write like this, h tending to 0. So it will be k divided by 2 into root 3 plus 1, which is 0. So it is 2. So it is k by 4. Okay, and if you will find the right hand derivative, g dash 3 plus, so it is simply, it is m, because m is a constant. So it is m. So if both it is differentiable, then definitely left hand derivative should be equals to right hand derivative, and it is k by 4 is equals to m. So from here you will get one equation, k is equals to 4m. So equation 1, but we need to find k plus m. So again, so the same thing that we need to find other equation. Okay, so other equation, how can we find? We have to check the continuity also at that point. Okay, so we will check the continuity at that point. At x is equals to 3, it is continuous also. So what is LHL? LHL will be limit x tending to 3 minus, and then it is k root under x plus 1, right? So I can write 3 minus h plus 1. So it will be, and h tending to 0. So it will be k root 4. So it is 2k. Similarly, if we find RHL, limit x tending to 3 plus h tending to 0, it is what? Mx, right? So m into 3 plus h plus 2, right? So it is again h tending to 0, so it is 3m plus 2. So if it is continuous, then what? LHL should be equals to RHL, right? LHL should be equals to RHL. So what we can do? We can write 2x is equals to 3m plus 2. Right? So this is the second equation. What is the first equation? K is equals to 4m. So this is equation number 1. So what we need to do? Just solve both the equations. So if we'll put k is equals to 4m, it will become 8m is equals to 3m plus 2. So 5m is equals to 2. So m is equals to 2 by 5. Similarly, if you find k, it is 4 into 2 by 5. So it will become 8 by 5. Okay, so we have got k value and we have got m value. So what will be the k plus m value? So 8 by 5 plus 2 by 5. So it will be what? 8 by 5 plus 2 by 5. It is equals to 10 by 5. That is equals to 2. So 2 will be your correct answer. Is it clear, everyone? Is it clear? सबको क्लियर है ना? समझ में आया? जल्दी जल्दी से बता दो आप लोग। ओके, सो एक ग्राफिकल वाला क्वेश्चन ले रहे हैं, ठीक है? एक ग्राफिकल वाला क्वेश्चन ले रहे हैं सो दैट कि आपको पता चल जाए, यू आर एबल टू अंडरस्टैंड. सो व्हाट इट इज, we have a function in this form, max of minus of mod x comma minus of root under 1 minus x square. It means what? We will draw the graph of minus of mod x and minus of root under 1 minus x square. And then what we need to do, we need to check in the interval where which function is maximum. Okay, and we should done it only in minus 1 to 1. Okay, so first of all, I suppose I am taking this as f of x and this is of g of x. So what is f of x? It is minus of mod x. And what is g of x? It is minus of root under 1 minus x square. Okay. Okay, so we need to check maximum, the function main. I can't take f of x, so just because f of x is already there, so what I am doing now, I will take it as hx, right? I can take it as hx because it will be more good. So I am taking this as hx. Okay, so this is your hx. So what we need to find, the function f of x is defined as maximum of hx and g of x. Okay, and then that function को हमें check करना है कि at how many points the function is not differentiable. So this can be done using the graph formula. Okay, so I think you know that this minus of mod x. So what we can do, we can draw the graph. Okay, we can draw the graph of minus of mod. It will be like this. Okay, the second thing is what, this is gx is minus of root under 1 minus x square. So if you will see, y is equals to root under 1 minus x square. So it is nothing but y square is equals to 1 minus x square, or x square plus y square is equals to 1. Okay, so this is nothing but a circle. Okay, this is a circle of radius 1. Okay, and if it is plus, then it is the upper circle, and if it is minus, then it is a lower circle. Okay, because plus value will be only, this is y value, because root always gives positive value. So I will draw the graph. Okay, so this is the gx graph, that is minus of root under 1 minus x square, and this is the graph of hx, that is minus of mod x, if you know the graph. Okay, and we know that the radius is 1, so it is minus 1 to 1. Okay, now what we can do? So we need to check in the interval from where to where which function is maximum. So I can see this, there is a intersection point, I can call it alpha, and here I can call it beta. So both, one is alpha and other one is beta. Now if you will see, from minus 1 to alpha, this is the minus of mod x function. Sorry, this is the minus of mod x function, and this is the circle function. So which is maximum among these two? So obviously this circle equation. So the function which is maximum, we will keep that, and other part will be deleted like this. We can delete this. Okay, because this is minimum. Okay, now from alpha to beta, if you will go, so here if you will see, this mod function is maximum and this is minimum. So what we can do, we have to delete the lower function, because now circle equation, the graph is minimum, so we have to take maximum. Okay, now from b to 1, if you will see, again the circle graph is more maximum and this graph is minimum. So what I will do, I will take this one only. So those who we have removed, that is done. So now the function is defined as like this. This is from -1 to alpha. This is maximum from alpha to beta. A mod is maximum from beta to 1. Again, this circle is maximum. So the graph will be like this, like this, like this, like this, and like this. Okay, so one point is what? This is alpha, this is beta, and this point is 0. So if you will check, then you will got to find there are three sharp turns. One is this, other one is this, and other one is this. So by just looking at the graph, you can see this graph is a what? Continuous function, but there are three sharp turns there. Okay? There are three sharp corners. Three sharp corners. So it means at 3 points, it will not be differentiable. So how many points it will not be differentiable? There are 3 points. Okay, is it clear, guys? Jaldi chat box mein batao if it is clear or not. Okay, so for these kind of question, what you can do, you can just you can in some of the question you will see minimum. Okay, so in this case, what will be the graph? If it is minimum, then the graph will be like this, because we are talking about only minimum. So in this case, there are only 2 points where it is sharp curve. So in the case of it is minimum, then you have to take only 2 points. If it is case of maximum, so but you should have a good idea about the graphs and all. Okay, so you can solve this kind of question. These kind of question are very frequent in today's time. Okay. Okay. So yeah, so that's it for the differentiability part. We will again keep one previous year questions session on all these topics. So that's why I have taken only 3-4 problems. Okay. So we will see in some other days. Okay, in the coming classes. So now we will start with method of differentiation. So I will just simply explain you simple thing, because method of differentiation is very easy, right? Because what we are going to do, we are simply going to do the differentiation. Okay, you already know in the 11th class, because in the physics you were always doing the differentiation thing, so you already have some idea about differentiation, all the basic formula that you need to know. Okay, you already know. So differentiation is what? It is nothing but simple rate of change of one quantity with respect to another quantity, dy by dx, that you already know. In physics, we have seen that rate of change of displacement with respect to time is called velocity, and rate of change of velocity with respect to time, it is called as acceleration. You already know. Okay, so dy by dx, you can say ds by dt, dv by dt, anything you can say. It is differentiation only, right? So this is the introduction part. So now, these are the some standard formula that you are seeing since a long time, that dy by dx of constant is equals to 0, x to the power n. So these are the differentiation formula that you already know. So just I am showing you this formula. Okay, no need to waste our time here. Okay, so these are the formula that already you should have. You should remember this formula, otherwise problem हो जाएगा. ओके इसके अलावा भी ये सारे भी फॉर्मूले हैं. लास्ट 3 फॉर्मूला इज नॉट सो मच कॉमन होता नहीं है, बिकॉज ज्यादा क्वेश्चंस में यूज नहीं होते, बट बिफोर दैट टिल 17th it is there. Okay, so try to remember up to 16. Always it should be always in your mind, then only you can solve the problems. Okay, so basically I hope you have understood the things, you know this formula. Then what we are going to do, we are going to see some theorems on differentiation. It is very small theorems, like if any function is given and if we will multiply it with some constant, then we can take constant out and we can do the differentiation for the rest of the part. Okay, just like if it is y is equals to tan inverse x, so you know that dy by dx is what? 1 divided by 1 plus x square. So if y is equals to 5 tan inverse x, so if 5 is constant, if we are taking dy by dx, I can write like this, d5 into dy by dx into tan inverse x. Okay, so it is what 5 into 1 divided by 1 plus x square. Simply we can take it out. Okay, the first thing. Other one is, if there are so many functions and all are plus minus plus minus plus minus, so what we can do, we can separately write the differentiation part. Like suppose y is equals to sine inverse x plus ln x plus e to the power x. So if dy by dx we have to find, we can find for the separately. This is sine inverse x, we know that it is 1 divided by root under 1 minus x square. Ln x, we know that it is 1 by x or e to the power x. So this will be your differentiation. So these are the small theorems that you need to know. Okay. Okay. So now we can see product rule. Product rule is also very, very easy and rememberable. F of x into g of x. If two functions are in product form, we can take one function, we can do the derivative of other, and we can take other function like this. In some of the cases, you will see like this, u into v. This is u, do the derivative of v, take v, do the derivative of u. Okay. So this is the product rule. Okay. Similarly, these are the two functions are in the quotient form, like divide form, like du, dy by dx and u by v. What you need to do? Just take the v ka whole square, keep v as constant, take the differentiation of numerator part, that is u, then minus, then take u and differentiate v. Okay, so this is the quotient rule. Okay. So no, I'm not going to solve any question on this product and quotient rule, because in every questions we are doing it already. Okay. So yeah. So now chain rule. Okay, I have not posted any kind of pictures over there. I will simply explain what is chain rule. I hope you have idea. So what is chain rule? Okay. So suppose I have one function y is equals to sine x, and we have to find dy by dx. So I can simply write, we know the formula, I can write cos x. Okay, but suppose we have y is equals to sine 2x. So what I will do? Okay, so if I will write dy by dx, so if you don't know the chain rule, you can simply write cos 2x, but it is wrong. Okay, it is wrong. And what is the correct answer? It is 2 into cos 2x. So now you will ask how it came. Okay, how it came. Okay, so you know that whenever we are defining the differentiation, we have seen some standard formula, right? So we are differentiating this y with respect to x. So if this sign is in the function of x, so it should be x only. But here what happened? It is the function of x, but now in the main thing it is 2x. And here it is x. So always whenever we are differentiating, the function should be always same. If it is x, then x. But here it is 2x. So what we need to do? We need to just keep it like, we can consider it as t. If we are considering it as t, so what it will become? Y is equals to sine t. But we have to find dy by dx. So what we can do? We will apply like this, dy by dt into dt by dx. Okay. So we know that now I can write now, because t ko we have considered 2x. So it is dy, in place of y I can write sine 2x, and in place of dt I can write 2x. And similarly in place of t we can write. So that's why you can see this is sine 2x and this is 2x. So now I can write it is cos 2x. And then into, then again one extra thing is come, it is 2. So it is 2 cos 2x. Okay. Because, so now you can see there is a chain. Okay, dt can cancel out, and still it will be dy by dx. So this is a very small problem. So what if I will take this one? Like y is equals to 10 x cube plus 3x plus 5. Okay, so now you know that key if y is equals to 10x, so it is sec square x. Okay, so what I will do, I will take this as t. Okay, so now it will become 10t. So I will find dy by dt and we will do dt by dx. So what is dy by dt? So it is 10t, so I can write it is sec square t. And what is dt by dx? It is x cube plus 3x plus 5, so I can write 3x square plus 3. And what is sec square t? So sec square in place of t, I will again write what is t? X cube plus 3x plus 5 is equals to into 3x square plus 3. So what if you will consider this, what you will observe that if it is 10 something, I will write sec square something, but again we have to go inside and then we have to find the derivative of that function, x cube plus 3x plus 5. So it will be 3x square plus 3. Okay, so now I am going to generalize it. Okay, now I am going to generalize it. What is the format? Like, suppose we have y is equals to f of g of h of x function, like composite function. Chain rule is nothing but you can say differentiation of composite function, like this kind of function coming. And someone is saying that if you have to find dy by dx, so what we need to do, I will consider this as t. Okay, so now what will happen? It will be dy by dt. Okay, dy by dt. Again, there is a t. In t, there is again an inside function. So hx, I can consider as p. So again, it will be dt by dp. Now in p, again inside we will go, it is x only. So now we have got this. So dp by dx. So you can see there is a chain formation. Okay, chain forming. If chain forming, so what I will do, dt cancel out, dp cancel out, is dy by dx. So now what will happen? You can see if I will write, it will be d of f of g of h of x divided by d of g of h of x into d of g of h of x divided by d of h of x, and then this is d of h of x divided by d of x. So this is your chain rule. Okay, so I will take one or two examples, then only you can see. Okay, so what we are going to do, I will take one example. Okay, so y is equals to, suppose I am taking sine log. Okay, and then I am taking sine inverse x. Okay, sine log sine inverse x. So you can see this is a complete example of composite function. So you need to find which is f of x, which is g of x, and like this. So now I will say keep this is sine, so it will be, suppose f of x, this log again inside function, it can be g of x, and sine it can be h of x. So what you need to do, you need to find dy by dx. Okay, so what you will do, after sine you can take this whole as t. Okay, and then again we will go inside, it will, if we can consider this as p. So now what we will do, we will simply write dy by dt, and then we will write dt by dp, and we will write dp by dx. So what is dy? So it is sine, in place of y I will write log of sine inverse x, right? Because this is your y, this whole is y, and divided by t. What is t? This is log sine inverse x. Okay, then again we will go log of sine inverse x divided by d of sine inverse x, and then again we will go inside and sine inverse x divided by dx. Okay, so now you know that this is what? This is t, right? And this is also t. So I can write now d sine t divided by dt. And what is this? This is p, right? So sorry, this is p, right? So what I can write, d of log p, right, divided by dp, right? And this is what? This is simply, this is p only. So this is no matter. Okay. So now this can be what? D sine inverse x divided by dx. I can simply write 1 divided by root under 1 minus x square. This is easy. Then sine t, I can write now cos t, sine t divided, because now it is tt. And then this is log p and p. So I can write 1 by p because log p is 1 by p. And then b divided by 1 minus x square. So that's what we are getting, right? And we have the values, right, for the t also, for the p also. So we can again, whatever we have assumed, we can put it back. Okay. So what is this? Like it is cos t 1 by p into 1 divided by root under 1 minus x square. Okay. Okay, so in place of cos t, what we can do? You can see we have t. So what is t? It is log of sine inverse x, right? Log of sine inverse x. So you can write it log of sine inverse x. And then what is p? It is 1 by sine inverse x. And then root under like this. So basic idea is what you need to do. You can see the equation. This is sine something, so it is cos something. Okay. And then again we will go inside. In something is nothing but log something. Okay. So again it is 1 by something. Okay. And then after that again we are going, it is sine inverse x. So sine inverse x can be easily done. So at the last step, if it is hx, then it will be easy and you can easily calculate. Okay. So I hope you can see the pattern. Okay. Okay, I hope, because these are the differentiation, you already know the chain formula. Okay, so now we are going to see some of the differentiation where trigonometry involved. Okay, like because in the most of the questions you will see there are lots of trigonometry involved. Okay, in differentiation. For that, what you need to do, you need to just remember all the formula, trigonometric formulas, everything. Okay, so that it will be easy. Okay, so I am just showing you differentiation, what we can do. So there are some substitution already, because you have seen in the inverse trigonometry, because there are some function which is very complicated. Okay, we can't simply find the differentiation. We can find, but it will be taking a lot of time. Okay, so if we will find these kind of format, okay, like root under a square minus x square, root under x square plus a square, x square minus a square, root under a minus x divided by plus x. So there are some substitution that you have already seen, I guess. Okay, in inverse trigonometry, if it is root under a square minus x square, in place of x I can put a sine theta. Okay, if it is x square plus a square, I can put x is equals to a tan theta. Similarly, if it is x square minus square, I can put a sec theta. The logic behind it, because a square 1 minus sine square theta, it will become cos square theta, and we can easily remove the a square root. If it is x square plus a square, if I will put a tan theta, it will become a square tan square theta plus a square. So it will be 1 plus tan square theta. I can write it sec square theta. Root will be removed. So that's why we are taking, so that we can remove the root also. Okay, so based on this, I have taken one example. Okay, so we have one examples like y is equals to tan inverse root under a minus x divided by a plus x, and we have to find dy by dx. Okay, so what I will do, so I can directly also use the chain formula, no problem, but it will take a lot of time. Okay, and the solution will be very lengthy. Okay, so what we can do, we can simply substitute. Okay, what we can do, we know that it is root under a minus x divided by a plus x. So just now we have seen a format. If it is root under a minus x divided by a plus x, we can take x is equals to a cos 2 theta. Okay, so we can take the substitution. Okay, that is a cos 2 theta, right? So let x is equals to a cos 2 theta. First of all, we will simplify it and then we will do the derivative. So it is tan inverse root under a minus a cos 2 theta, and it will become a plus a cos 2 theta. Okay, so now if you will see, I can take a common 1 minus cos 2 theta and divided by a, it is 1 plus cos 2 theta, and this will be cancelled out. And I hope you all know this very famous formula. Okay, 1 minus cos 2 theta, and this is 1 plus cos 2 theta. Okay, so this is your 2 sine square theta, and this is your 2 cos square theta. It is just like 1 minus cos theta or 1 plus cos theta is most used formula in the history of trigonometry. You can say if it is CSK, this is RCB. Okay, these are two famous because CSK is more famous now, so that's why I have written. Okay, like 2 cos square theta and 2 sine square theta, right? So now what will happen? It will given 1 tan inverse root under 2 sine square theta divided by 2 cos square theta. So 2 will be cancelled out. It will be tan inverse root under tan square theta. So it will become tan inverse tan theta. So now you can see how it is simplified. Like, so now what is we are getting theta. So the simple that value what we are getting as theta. So it become very simpler form. Okay. Okay. So now what is happening? We are getting y is equals to theta, but we need to write this in x format so that we can find the differentiation. So theta will be what? From here we can find theta. If x by a is equals to cos 2 theta, so what is 2 theta? It will become cos inverse x by a. Okay, so theta will become what? 1 by 2 cos inverse x by a. So now we have got a simpler value, that is 1 by 2 cos inverse x by a. Right, so this is your y. Okay, you can ignore this question for now. So what is we are getting? Y is equals to 1 by 2 cos inverse x by a. So now you can find dy by dx. So I hope you know the formula. 1 by 2 cos inverse x. Okay, so cos inverse x, the formula is minus 1 divided by root under 1 minus x square. So I will write minus 1 divided by root under 1 minus x. In place of x, I will write x by a ka whole square. And you know that it is x by a. Again, if we are taking it as t, it is forming chain. So we can write dy by dx of x by a. So it is minus of 1 by 2 root under 1 minus x square by a square. And it is what? 1 by a. Okay. After solving this, you can simplify it. It is a square minus x square into a, and this is 1 by, because this a will go upper side, a will be cancelled. The final answer will be minus 1 divided by 2 root under a square minus x square. So it is more easy, right? And in this question also you can see root under 1 minus x square. So what substitution you can take? It is in the format of root under a square plus x square. So if it is like this, you can take x is equals to what? A tan theta. But in this case, 1 is there, so you can take x is equals to tan theta only. And just after solving this, you will get a simpler equation. From there, you can find the differentiation. Okay. Is there any problem? JNV, Bijayanagram, JNB Mahe. Mahe, I don't know. I have never heard about this Mahe. So is it a short form or some other thing? Can anybody confirm? Okay. So the last one that we are going to discuss, that is derivative of parametric function. Parametric function. So what is parametric function? I hope you have heard about this term, that is parametric. sorry, parameters. Means till now we were solving the problems. Okay. Oh, sorry guys. I thought it is in Maharashtra. Okay. Thank you for your confirmation. Okay. Yeah. So derivative of parametric function. So what is parametric function? So till now we were discussing about that y is equals to f of x, so we can find dy by dx. But now you will see some of the functions where y and x are not dependent on each other, but y is dependent on some other variable, some other functions. Okay, and x is also at the same time x is also dependent on that. Like suppose we have one function y is equals to f of t. Okay, and x is some other function that is g of t. Oh, means y is dependent on t and x is also dependent on t. So there is no direct relation between y and x, but both are dependent on a third parameter, that is t. So that t is called as parameter. So in this case, if someone will say find dy by dx, okay, so we know that it is not in x format, so but it is in t format. So what I will do, I will find dy by dt first, and I will find dx by dt first, and you know that dt will be cancelled out and it will become dy by dx only. So if this is y, if you will find dy by dt, so what you will get? You will get f dash t, and if you will find dx by dt, you will get g dash t. So what will be your answer? It will be f dash t divided by g dash t. This will be your answer. So if the parameters are given, okay, and you have to find dy by dx, so first dy by dt and then again dx by dt. Then divide it, you will get dy by dx. So one examples I have taken. Here you can see x is there and y is there, but both are dependent on what? Theta. So here the parameter is not t but theta. So I can write x is equals to, this is g theta, and y I can write f of theta. So what I need to do, we need to find dy by dx. So first we need to find dy by d theta, and other one is dx by d theta. So what is dy by d theta? So we have y, right? What is y? It is a into 1 minus cos theta. So if I will find dy by d theta, so what will happen? A 1 0 minus of minus plus, it is sine theta. So what is dy by d theta? It is a sine theta. Okay. Similarly, x we know. X is what? A. This is theta plus sine theta. So if I will take a because it is a constant theta, if we are finding dx by d theta, so theta d theta by theta, it is 1, and plus sine theta is what? Cos theta. Okay, so we have find dy by d theta and dx by d theta, but we have to find dy by dx. So what I will do, I will put dy by d theta as a sine theta, and I will put dx by d theta as a into 1 plus cos theta. So a will be cancel out, and this sine theta divided by 1 plus cos theta. So this will be your dy by dx. Okay, in some of the cases you will see the answer might different. It will be tan theta by 2 also. So you should have some idea about the how to convert it. Like sine theta, I can change it in 2 sine theta by 2 into cos theta by 2, because you know the formula sine 2x is equals to 2 sine x into cos x. If it is 2x, it will become half, but here it is theta, it will become theta by 2, theta by 2. Simply, it is 1 plus cos 2 theta. Just now we have seen the formula. 1 plus cos 2 theta is equals to 2 cos square theta, the RCB part. Okay. So it is cos theta, so it will become 2 cos square theta by 2. So 2 will be cancelled out, and cos theta cancel with this. So it will become sine theta by 2 divided by cos theta by 2. So it is tan theta by 2. So this is just a conversion, but actual answer is this. Okay. So I hope it is clear to all of you guys. Dy by d theta, dx by d theta. So I time is over now. So you can solve other questions also, like this question. If I will say, so what we can do, this is a dy by dtt I will find. So it is a, it is sine qt, sine qt, right? So this is 3 sine square t. Again we will go by the chain rule, sine t will be cos t. So this is d by dtt. Similarly dx by dt will be what? It is a cos qt, it is 3 cos square t into what? Cos t is minus of sine t. So if I have to find dy by dx, so it will be dy by dt divided by dx by dt. So what you can do, just do the calculation. Okay, like this, a 3 cos square t minus of sine t. So a will be cancelled, 3 will be cancelled, 1 cos t will be cancelled this. So what will be the answer? Minus sine t divided by cos t. So final answer will be minus 10 t. Okay, so this is clear. So these two problems for the homework for you guys, for your practice. Just solve these problems. It's very easy. Okay, you just should have basic idea about product rule, chain rule, and everything. Then you will never trapped in the problems of differentiation, because it is very easy. And if you know that these kind of for derivative like parametric, in the coming part we will see logarithmic functions, differentiation of one function with respect to other function, everything. So if you will see this, then it will help you in application of derivative, and you know that application of derivative is a very big chapter. So for that you need this this differentiation concept clear. Okay, so that's why you can solve these problems also. So from there I will start, because here there are some needs of that inverse trigonometric relations also. So that's why I'm stopping here. So in the from the next class I will start from here only. Okay, and then we have some other forms. Okay, like derivative of one function with respect to another function, then logarithmic function, then infinite series, then we will also see determinant of differentiation and all these things. So that's it for the today's class, guys. So I hope you have liked my class. If you are having any problem regarding not understanding everything, or so you can just share your concern through the chat box also, so that from the next class I will try to make it more understandable to you. Okay, because time is very limit. So, and yeah, I can see you guys are not attending from the start, so that's why in middle of the class if you are joining, then I couldn't find that key from where I had to explain and all. So I would expect you from the next class you will be in my class from the start only. Okay, so that's it for the today's class, guys. Bye bye. Take care. Okay. Any doubt you can drop, otherwise you guys can leave. Thank you, guys. Thank you. Thank you, Vijay Nagram. Thank you, Jain B. Mahe. Thank you, YouTube people.